What an incredible presentation with a global collection of case studies on bespoke smart city solutions, data visualizations, scanning, new ways of data collection, and who knows that we can actually go into Safety and map cities and try and help avert pandemic. So thank you, Fabio. Each time I see MIT Sensible City Labs work have been over the last decade, I get more and more impressed. And next speaker is no less a rock star in smart cities. Anthony Townsend is a senior research associate at Cornell Tech's Urban Tech Hub. He's an internationally recognized expert on the future of cities and urban technology, leading the development of multidisciplinary research collaborations with stakeholders in industry, government, and civil society. Anthony is the author of 2 books. Both, again, are actually must-reads in my class here. When I take any class, I say you must read these books. And I say that to the audience here as well, Ghost Road, Beyond the Driverless Car, and Smart Cities, Big Data, Civic Hackers, and the Quest for a New Urban Utopia. These 2 books are a must-read for smart city enthusiasts. His work has attracted nearly 6,700 citations, and one of the highest again in the field. His major projects he leads include Rethink AI, a collaboration with the New America Foundation. He will present the findings from that study. And also he leads the Cornell Initiative on Aging and Adaptation to Extreme Heat. So we're gonna get some interesting insight on how smart cities and resilience could be interlinked with technology and AI. So with that, welcome, Anthony.
All right, good morning, everybody. Thank you for having me here. I'm really excited to be here. I spent the morning walking around this beautiful new campus, and it gave me a bunch of ideas for our own campus expansion. Hi. Okay, so I come from New York City, which, contrary to Fabio's remarks, actually is still growing. Since I moved there in 1995, New York City has added 1 million people, and we're on track to add another 1 million people by 2070. So it's a big city, it's a growing city, it's an old city, but it has a lot of new parts, including our campus, which actually is a creature of the city. It is the first new engineering campus in New York City in 50 years. It was created in 2012 by Mayor Michael Bloomberg as a reaction to the financial crisis, where the mayor saw that the city's economy was too dependent upon financial services and wanted to diversify it and created a competition, basically. We swooped in with a very wealthy donor, stole the prize from Stanford, and established this campus in partnership with the Technion Institute of Technology in Israel. So we care very much about cities. We don't have departments, we just have these things called hubs. The Urban Tech Hub is the 3rd and final one, which launched in 2020. And so we're really trying to understand the role, particularly that AI, which is the central focus, our North Star for the campus. You could argue we're the first university campus anywhere in the world to focus exclusively on AI. And we did it before ChatGPT was launched. So I guess we're the old kid on the block. But as you see, we're surrounded by water. Like Southern Florida, we are extremely vulnerable to sea level rise. And we are expanding, we're growing. This green field on the left is where the 2nd phase of our campus will go. So we're really focused on climate right now. The problem is that those 2 things are kind of incompatible. Right now, AI seems mostly to be working against climate action. And you see that in the boom in electric power demand that's being driven by the current wave of AI investment and innovation. This is the McKinsey graph, which is actually, I think, a little subdued compared to some of the graphs you'll see from folks on the other side who are trying to sort of push back against this. But what it really speaks to is the tech industry directly competing with basically every other sector of the economy for the still limited amount of clean renewable energy that we're able to produce, at least in this country. And they're going to be taking more and more of that as time goes on, assuming things continue on a straight line. And it's not just energy, it's also other resources like land and water. If you want to sort of really understand the direct conflict here, just look at what Elon Musk's AI company, the conflicts that they're having in Tennessee. I think it's in Nashville. Is it Nashville or Chattanooga or Memphis? I can't remember which city. But their new data center, which will be massive, one of the biggest ever built, is going to be demanding a significant portion of the city's fresh water supply just to cool the servers. And this is something that's alarming lots of folks. So, these conflicts over AI data center siting are going to be very localized. They're going to raise all kinds of issues that I don't think cities are really prepared to deal with. And this is the new infrastructure of the cloud that's being built out right now. Boom. Okay, so compounding on that problem is that I have been documenting this for 20 years, and I'm kind of surprised to see it playing out more or less on the same script, is that even when tech companies try to do climate good for cities, they often make the same old mistakes. So this is a promotional reel that was prepared by Google about a year ago about a project they call Project Greenlight. And what Project Greenlight was basically an effort to take all of the mobile location data, similar to what we saw before, that Google has accumulated through its Android operating system, with kind of dubious consent about how that location data is being collected, with the goal of eliminating stop-and-go traffic on the street networks of cities around the world. And the solution was to optimize the timing of the streetlights to reduce queues at red lights in cities. This is great if you're a motorist. It makes your trip easier. It does actually reduce emissions, if you believe the model, but only from that mode of transportation. And in the process, what it does is roll the clock back on probably 30, 40, 50 years of thinking and planning and intervention around complete streets. So, what I love here is how they show like these cars cruising through the zebra crosswalks, no pedestrians in sight, no mention of pedestrians. And if you dig into the modeling that they did, they actually completely left pedestrians and cyclists and all of the other lower modes, emission modes of transportation completely out of the question. This is now being rolled out into dozens of cities around the world, and I think is like a major step backwards. And my suspicion is that it's because what Google was looking for was some cover for all of the other things that they're doing that are walking back from their zero emissions targets because of AI. So this is a really, I think, terrible feedback loop. It's a regression to some of the mistakes that we saw in smart cities, like in 2008 when IBM kicked a lot of this off, and that spurred me to write my book and go around and point this out to people. And so it's really, I think, alarming to see the same old mistakes being made. And we need to keep that in mind, and we need to push back. There's an op-ed I wrote in City Lab, Bloomberg City Lab, about this, really just contrasting Google's claim to reduce delays by 30% with the fact that, the year they launched this project was the peak year for pedestrian and cyclist fatalities in the United States. Okay, so I don't know how this is going to shape up. There may be some silver bullet that comes and reduces power demand for AI. We're still going to see these climate mitigation fails using AI from the industry. But what I'm focused on right now, what I think is a real opportunity, is using AI for climate adaptation in cities. So how do we deal with the effects that are already baked in or will be coming down the road? This is a future that's already taking shape. We have been working for the last 3 years with a Paris-based think tank, Urban AI, to do a weekly series of webinars every fall. We call it Future of Urban AI. This is, I think, from the 2022 session. And really what we're trying to do is just build a grassroots networks of PhD students, young researchers, public entrepreneurs and city governments, social entrepreneurs who are shaping the future of urban AI. And what excites me so much about this, and I'll come around to at the end, is that I think that the challenge of urban climate adaptation is so great that it could potentially exert a force on the evolution of AI itself. The way that we've been studying this is using a kind of qualitative futures methodology that's based on collecting lots of signals, examples of products, services, behaviors, research findings that are in the world today. They're real tangible artifacts, and then aggregating and synthesizing those up into higher level trends and forecasts. This is all available at the Future of Urban AI. It's kind of I think of it as a Wikipedia of the future. You're welcome to explore, to contribute, to share, and we're continuing to add to that. And what I want to do is just share the three kind of high-level forecasts and a bunch of examples that I think will show you some of the potential that I see. The first forecast really has to do with sensing. We saw a lot of great examples earlier about sensors that are being deployed. I call this expansive views. And in my mind, this is really a story about how the way that we measure risk and resilience of cities is going to be transformed. I think it takes the shape of things like using drones to map urban heat islands in like excruciating detail. If you know anything about urban heat island work, it's mostly simulations. We have some satellite data, and then everything else that's smaller scale than that is almost always modeled. This is just one of many research groups in Graz in Austria that they're flying drones over public plazas, doing I think 30 centimeter scale grid maps of the temperature, and then designing interventions, designing heat mitigation measures, and then flying the drone back over it the next summer and seeing how they improved. This to me is the future of heat mitigation design in cities. There's a lot of work. We did a little bit of this in Cornell Tech in a project called Treefolio around getting better data and using it to manage the urban canopy. Trees, which is probably the single most effective, widely used tool we have for reducing heat in cities. And this is more than just taking pictures of trees from the sky. This is actually using machine learning to isolate the portion of that image that is associated with each tree. And so rather than modeling the canopy as a forest, you can model each tree, which allows you to better understand and develop methods for ideally placing trees, for measuring the benefits of individual trees. It's really like taking a very coarse science. The way most cities measure tree canopy now is how much of our land area is covered by trees, which doesn't really say anything about like, are the trees near schools? Are they in environmental justice neighborhoods? Who is getting the benefits of the trees, and what can we do to improve that? And this is really, I think, a larger effort towards quantifying the natural capital of cities so that we can manage around that, we can govern around that and preserve it. Boom. Okay, this is crazy. This is a group at NYU's Courant Institute led by a professor, Signing Z. He has developed multimodal AI agents. So these are little pieces of software, you can think of them as bots, that like ChatGPT can understand anything you throw at them, text, audio, video, images, and he gives them these little characters, and then he sends them out into Google Earth, okay? Virtual representations of our actual cities. So they're out there exploring these Google Street View images, and they're doing real work. So you can, in natural language, like ChatGPT, tell them, hey, can you go and count all of the park benches in Central Park? And these bots will traverse that virtual path network of Central Park, look at every view in Google Street View, and identify all of the park benches. Now, that's like a really trivial application, but imagine if you were doing a asset inventory of a vulnerable neighborhood. I want to identify all the resilience assets. You can very quickly deploy software to go do that. and help you gather that data that you need. You can imagine this being used for post-disaster assessments. It just has a million applications. Like my head kind of explodes when I think about the power for, sort of labor capacity-strapped city governments for community-based organizations to use these kinds of tools. Of course, it requires having access and good data going in, but again, sort of some of the crazy thinking that's going on. The second forecast I call optimized insights. This is really about the future of sense making, the future of analysis. And for me, this is about thinking machines becoming part of the teams that are planning and running future cities, and making predictions that will support tough human judgment calls. And I worded that very carefully because this is not about machines making decisions for us. This is about decision support. When I was at MIT in the late 90s and I was in the GIS group in our planning school, we called it planning support systems because we wanted to be so clear to everybody else in the school that we are beneath you, we support you. We build tools to help you do the things that you care about: urban design, environmental planning, international development. This is a tool set, not a displacement, something taking over your job. And I think that that's going to be really important to emphasize, particularly as these tools become incredibly powerful. Getting back to GIS, I always tell people the most valuable language I learned, second language, was structured query language, learning how to get things out of complicated databases reliably. I don't think people are going to learn that anymore when they do spatial analysis because chat interfaces for GIS are getting so good that you can do things like in this example, where you can identify all of the parcels in an entire city that are at flood risk in like 15 seconds and plot that out. I'm getting pretty good at this behind the back move. Here's another great project that takes advantage of generative AI. This is, it's called FloodGen. It was built by a civic tech group in New York City called Beta NYC, which are really, they're sort of the stewards of the city's open data community. And what they did was they identified a number of flood-prone neighborhoods around the city that are also environmental justice neighborhoods, and developed a interactive tool that allows you to view these artificially generated images showing what different levels of street flooding look like under different scenarios. And you can do that sort of like slider interface thing that's very common now. And this was an incredibly powerful tool for allowing people to spur debate in local communities with elected officials, about the risks that they face and trying to get the city to think more clearly and urgently about the kinds of preparations that they could make. And then, one of the other things that we see, I know the University of Miami has a really important, well-respected resilience institute here. Not every city has that. And this is the Climate IQ project at the New School in New York City, the Urban Systems Lab. And what Climate IQ is trying to do is build a hazard dashboard for every city that's based on physics-based models. It incorporates remote sense data. And really the idea here is that, not every city is going to be like New York or Miami or Amsterdam and be able to work with the university and build its own hazard dashboard. Climate IQ will essentially be like a software as a service that any city can plug into and at least get a basic level of awareness of the risks that it faces. And then this is another crazy one. So this is a consultancy based in Berkeley, and the name is escaping me. And their main product is a household location choice model. So they, basically simulate like why people move where they do, based on essentially housing prices and transportation access. And they have been playing around with using large language models to read the research literature on household location choice, and then figure out what's new in those findings that can be incorporated into their model, and then using the LLM to update the code of their model so that they can incorporate those new research findings. So this is really a signal into a future where the tools that we use to understand our cities are constantly reading the research literature and updating themselves and improving themselves, which is kind of a remarkable feedback loop that could really accelerate our resilient science quickly. So you can imagine, the next round of these models are reading all the papers about climate risk and how people make decisions about where to live based on not necessarily the actual climate risk, but their perception of the climate risk, which adds another layer of complexity, but also another lever for us to pull. And this gets to the third forecast, what I call amplified actions. And this really has to do with how, as humanity, and these are pretty global trends, there's some local variations, but we're getting older, we're spreading out, and of course we're gonna feel the heat. And heavy automation, I think, is an essential toolkit that we will need to lend a helping hand. And there's a bunch of signals of these. This is from Amsterdam. This is the Blue Roofs program. And this is essentially an effort to take green roofs and turn them into what I think of as like a stormwater management utility. So you have a green roof that can capture and retain water. You have one algorithm that's looking up at the sky, figuring out how much water is on the way, and then another one that's looking down through the storm drain system towards the water treatment plants and trying to figure out, okay, how long is it going to take the water I discharged to get there? How much other water is coming in? And when is that water treatment plant going to be overloaded? Because we don't want to discharge any untreated water into the waterways. And so think of it as like a battery for rainfall. It can simply store rainfall until it's time for it to be released in a controlled manner. Got to have lots of drones. This is probably one of my favorites. So Singapore's H3 Dynamics, they have a solution which is basically a solar-powered box you stick on top of a high-rise building, and every morning the box opens up and the drones come out and they take billions of pictures of the exterior facade of the building to identify defects. So this is like peeling paint, watermark, surface cracks, corrosion. And then they can even automatically generate the work orders to have those defects repaired. So this is a technology for a world, that we're going to live in at the end of this century, of labor shortages, of aging high-rise structures that we built to be more sustainable, but maybe we can't afford to maintain anymore. And they're going to be essential for maintaining a good state of repair for all of those cities. And then this is another generative AI tool that's been developed by Helsinki-based Urbanist AI. And this is essentially using image generation techniques to drive participatory urban design processes. And so the same way that you use ChatGPT to generate a picture of like a cat playing a violin on the tip of the Titanic, you can use it to generate alternative urban futures. And what this does is this takes, I think, the power that like commercial developers have had for many decades now of producing really beautiful, glossy, compelling renderings of their vision of the future of cities, and puts it in the hand of lay people, of citizens and communities, and allows them to not just say, but to show what they think urban resilience looks like in their communities. And it's really driving some interesting changes in how this planning gets done at a local level. So I think this is a future of like big opportunity, obviously lots of new risks. And I'd love to get into these in the discussion, but expansive use, more data is going to shift power, raises the question of who actually gets to use bigger and better data to engineer, and what kind of resilience do they engineer? Is it stronger defenses, or is it about moving away from risk? And what are the policy implications of that? These optimized insights are going to challenge local knowledge. I think the biggest risk of AI is that it's perceived And this goes back to the beginning of smart cities, that these things are seen as oracles, as like unassailably accurate, smarter than us, faster than us, and that we can't challenge them, and that they shift from being decision support to decision-making systems. And then, the amplified actions forecasts, I'm really worried about, the security risks of heavily automated infrastructure. I wrote in the Ghost Road book about a lot of stuff that was going on with Tesla that we knew about in 2018, and has since become only more pronounced. If you look at some of the national security literature on America's infrastructure, and it's kind of, a wide open door. Like, there are lots of people fooling around inside our infrastructure right now, and the more automation that we put on the edges of it, the more dangerous that gets. All right, almost done. So I think the future of urban climate adaptation is intelligence. You go to a lot of resilience climate adaptation conferences. It's about pushing dirt around. It's about very important sound things, but often people are very hostile to the idea that technology can play a role, and I think that we need to find ways to bridge that. And it's not just artificial intelligence. Human intelligence is first. Artificial intelligence can support that. And then there's all kinds of natural intelligence. Has anybody seen any of these AI apps that let you talk to your dog? They basically, people have built models that claim to interpret what different kinds of animal sounds are trying to say. And while I think that's crazy, I think there actually is a lot of potential, deeper understanding of the messaging that's floating around, the information that's floating around in the natural world that we can tap and even potentially talk back to. And that will be a path to greater resilience. But then I think there's this flip point, which is, can the challenge of urban climate adaptation, which really is the existential challenge of humanity over the rest of the century, be something that gets pushed back to the tech industry as a requirement for how we actually develop this technology, right? Because we see it going in directions that seem to be working against that. Can we voice the demands of urban climate adaptation that push us towards a leaner, greener, smaller kind of AI? And when I think about this is the image that's in my mind. This is the recently published by some folks at Berkeley map of the neural network of a fruit fly. It's about 140,000 neurons. It powers a robot that can do some really amazing things. It can fly around, it can get food, it can sense, it can fly, it can reproduce. It can get into tiny little cracks, in places and see what's going on there. Potentially, if it was a robot, repair, seal those cracks, do other kinds of interesting work. You compare this, it's also very, very energy efficient. Compare this to the AI models that we're building, pushing towards scale, 700 billion parameters and neurons. This may be, I think, the blueprint for the kind of AI that will serve urban climate adaptation better. And what I would like to see is, the industry start to think about how we can make models that are smaller, that are more built to purpose, serving human needs that are clear and much, much more energy efficient and therefore more sustainable. Thank you.